All right, welcome to another exciting edition of Comet Algebra. I know we're all thrilled to be here. This video starts Chapter 9, Section 9.1, Simplifying Rational Expressions. A rational expression is simply a fraction with a bunch of algebra in it. So its definition is the quotient of two polynomials. And one of the things we have to watch out for, of course, in our number system, we cannot divide by 0, so the denominator can never be 0. And this is where we will get our excluded values from. So looking down here at the steps, when we want to simplify a rational expression, the first thing we do is factor everything. After you factor both the numerator and the denominator, you can cancel out common factors, and then we will look at the excluded values. We'll have to check the denominator, and whatever makes the denominator 0 has to be taken out of the domain. The fraction cannot exist. It does not exist where the denominator is 0. So let's start with a straightforward example. When we are dividing these two monomials, you simplify the numbers just like you always have. So just the numerical part, the 91 over 14, they both have a common factor of 7. 91 divided by 7 is 13. And 14 divided by 7 is 2. So that part hasn't changed, just reducing fractions. And you need to remember everything you learned about exponents. How many are left and where are they located was how I phrased it. So this x squared cancels out two of these x squareds. There's one x left, and it is located in the denominator. This y takes out one of these y's, and so we have y cubed left in the numerator. And then that one is simplified. All right, this next example. Again, following the steps. Factor the numerator and denominator separately. Looks like both of these are going to be the GCF method. So in the numerator, both terms, they share an a in common. So let's factor out an a. And we get a squared plus bc. Factoring the denominator, these terms share a 2, and they also share a b. Factoring out a 2b from both of those, we are left with a squared plus bc. Step 2 is cancel out the common factors. So this entire factor divides this entire factor to be 1, and we are left with a over 2b, and that is simplified. All right, the next example. Again, factor everything. The numerator, it doesn't appear there's any factoring to do at all, so that's nice. This bottom one, these common, the GCF would be a 4. And then if we take out a 4, we're left with 3y minus x. Now let's take a look at what we have here. We almost have factors that can cancel each other. They are so close, the only difference is that the order is switched. So when we see this, I need you to learn this skill and have this as a strategy that's ready to go anytime you need it. When you run into this, and the only thing that's preventing us from canceling these is that this x is positive on top but negative on the bottom, and the 3y is negative on top but positive on the bottom, because we can change that. So we do what I call the -1 trick. You factor out a -1, and it doesn't matter if you do it in the top or bottom. I guess in this example I'll do it in the numerator. Factor out a -1, and it just changes the signs of both those terms. So the x becomes a -x, the 3y becomes a positive 3y, and I have not changed the denominator at all. And if you're a little OCD like I am, these terms don't look quite the same, so let's just change the order of this numerator so that it looks exactly the same before I cancel. So I'm just going to put this 3y in front and move the negative 6 to the back. And so it looks like 3y minus 6. And again, the denominator stays the same. And now these two factors are exactly the same, and I can cancel them. And my completely simplified answer is a negative 1/4. So just reviewing again, I want you to remember this. When the order is the only thing stopping you from canceling, factor out a negative 1 and change the order. And you can just check, do a quick distribution to make sure that this is mathematically correct. Negative 1 times negative x is this positive x, and negative 1 times this 3y is the negative 3y, so all we did was change the signs. So put this in your notes and have this negative 1 thing ready to go whenever it's needed. All right, again, repeating the process, factor everything. So the numerator looks like it's a diamond problem that will factor into two binomials. What do I multiply to get a negative 3, but add to get a negative 2? So if I have x minus 3 and x plus 1, do a quick FOIL and check. The inner product is negative 3, the outer product is 1. Negative 3 plus 1 does indeed add up to negative 2. And I hope we recognize this denominator as the difference of two perfect squares. So we have x plus 1, x minus 1. Look for any common factors. They have the x plus 1 in common, so those can be factored out. And we are left with the simplified fraction of x minus 3 over x minus 1. Now, when we're asked to state the excluded values, we always do the excluded values from this form, from the factored form. I can't see the excluded values before it's factored here. I just don't see it. But here it's quite easy to see what two values will make this denominator 0. If x plus 1 is equal to 0, that x that would be a negative 1. So we have to state over here that x cannot be a negative 1. Then we ask ourselves, what would make this factor 0? If x minus 1 equals 0, x would be a positive 1. So that is the other excluded value. So this is your fraction, this is your simplified answer, and these are called the excluded values. The values that make the denominator 0, and you do the excluded values step, you look for that in this factored form. All right, this last example is great because it combines pretty much all the different strategies we've talked about thus far. So we start by factoring. Looking across the numerator, there is a GCF of x squared. So let's factor that out first. And in the denominator, there's a GCF of just an x, so we'll factor that out. And looking at what we have left in parentheses up here, with this 6 in front, this is a diamond box problem, so you have an option of guessing and checking. If you guess and check, remember the options are 6x and 1x, and then the 2x and the 3x, so there would be some different ones to try here. If you don't like guessing and checking, you can always do the diamond box. So we have 6x squared on top, negative 5x on the bottom, negative 2x and negative 3x would multiply to 6 and add up to negative 5. So going to the box part of the problem, what goes inside the box is the first and last from the trinomial and the two factors that we found, negative 3x, negative 2x. Now here, be careful. We got to plan ahead. Are we going to use 6x and 1x? Looking here, the 6 won't work for the 3, and the 6 won't work for the 2, so that is rejected. it's going to have to be the 2x and 3x, and it looks like I need the 2x here and the 3x here. Here, to get a negative 3x, I'd have to have a negative 1, and here, to get a negative 2, I'd need a negative 1, and then negative 1 times negative 1 is positive 1. So now let's write out the complete factored form of both the numerator and denominator. And I am seeing that I have a 2x minus 1 in my numerator, and I have almost that same thing in the denominator, except they're switched around. I hope you recognize that this is that negative 1 trick that is needed. So let's go ahead and factor out a negative 1 out of the denominator. So I'll just put the negative sign in front of the x. It changes the sign of both of these. It makes this positive 1 negative, and it makes this negative 2x positive. So let's go ahead and switch the order, because I'm OCD and I like to see it exactly the same. So now we have both completely factored. Now let's just pause a minute. In the factored form, that's where we do our excluded values. So we ask ourselves, what makes this factor 0? Well, if negative x equals 0, x equals 0, so that is one of the excluded values. X cannot be 0. And then we have to ask ourselves, what makes this factor 0? Now don't be careful, don't always trust your mental math. Go ahead, if you need to, set it equal to 0 and solve for x. And we get a 1/2. So that's the other excluded value. X can't be 0, x can't be 1/2. So now that we have that part of the solution, now we can go ahead and start canceling. These two factors cancel. This x takes out one of these x's, and the only thing that's left in that denominator is the negative sign. So I'm just going to move it up to the numerator. So we have negative x times 3x minus 1. And that is the complete simplified version. So this is the answer with these two excluded values. All right, good luck with section 1. You have all the knowledge you need to do that.